Hey, I went down another rabbit hole, so I guess I'm going to talk about it. I wanted to talk a little bit about Tripath, what they did, what they accomplished, some of their chips. They did some other things besides audio. And I want to talk about, they call it their Class T technology, which is really Class D, a variation on Class D, what they did back then. And everything they did was kind of groundbreaking back then. So we have them to thank for a lot of the advancements in Class D. I also wanted a good little basic Class D theory here. What just a overview of simple overview of what Class D is, and maybe talk about some of the equipment that had used Tripath chips, some of these small amps, and some of the commercial, the high end, made a few of their amplifiers. But let me tell you how I ended up this far. It about 4 years ago, or not 4 years ago, excuse me. It was about 15 years ago. I had a flat screen TV that had really crappy sound on it. So I was a Parts Express, spent about $20, and of course bought one of these. Whoops, wrong one. One of these Lipi 2020A plus little amplifiers. You know, everybody's familiar with them. No use to go into that right now. But I had it hooked up to the TV through a couple old Optimus Pro AV speakers, which actually these are nice. I actually updated crossovers on them. Actually, I never did a video on these. Maybe I will. But I had it hooked up to the TV, left it on all the time, and had one of those plug strips, current sensing. So when I turned the TV on, the little amplifier came on, and that worked out for about 4 years. So after that, I threw the thing in a drawer and never thought about it again until I made that video where I took that old medical little monitor and was using that to feed my lossless audio files and my MP3s into my tube amplifiers. And I says, you know what? When I'm working on my computer, I need a little bit of sound, something that I have. Still need a little sound. So what I did was I pulled out that little amplifier and I plugged it in and used it to my PC. But just for the heck of it, I said, I wonder what this sounds like on my speakers. So I hooked it up and I was surprised. I guess after doing a little research, I was as surprised as everyone else of how well this dang little thing sounded. And since picked up this other one, it's a LP 2051. It's a 50 watt per channel using the same Tripath technology, and I'll play around with them. I actually plan on doing some upgrades. Everybody did upgrades, but a lot of the stuff wasn't common sense. Come on, you see guys in the forums, well, I tried this, try that, I changed this out. How about doing a little mathematics, looking at the specs of things and doing a little math and figuring out, do you really need to change that part? But I feel these things can perform good with, get rid of these. I already have an idea in mind, get rid of these crappy speaker jacks and the input jacks. I already got something worked out that I'm going to do, and replace the capacitors inside the input caps, put some good ones in, change the electrolytics, and I'm not going to bother with the output inductors. I don't think there's too much to do there, but that's another video. But anyway, I'm going to go in some detail here of things that I found out, and I am going to let my AI Fred do the narration for all this because, I have time. I forget half of what I'm going to say, so it's easier if I can, and I can change it on the fly. So bear with me, and you're going to listen to Fred and see, was Tripath really the giant killer that everyone said it was? And it interesting what would have become of them if they would have stayed in business. So grab a cup of coffee and sit back and enjoy.
Tripath made chips for several markets. All of these devices were based on Tripath's digital power processing technology. It was this signal processing technology that was used in their first audio products that was an improvement over existing Class D amplifier technology that caught the industry's attention, which Tripath coined the phrase Class T. With their digital power processing technology, they designed audio switching power amplifiers, audio digital processors, digital subscriber line drivers, and wireless CDMA digital power processors for the cell phone industry. I think there may be a misconception of what Tripath was trying to accomplish in the audio market. In my opinion, Tripath was not trying to compete with high-end audio. What they were bringing to market were small, low-cost, highly efficient audio chips with high-quality sound. Actual quality of the devices that they were used in depended on the engineering of the circuits and components that they were used with. In essence, sound for the regular guy, which is what they accomplished until the rest of the chip makers caught up. In October 2000, in an interview with Wall Street reporter, Dr. Tripathi said, "In order to really understand our business, I think it's necessary to describe just what an amplifier is and how it functions. An amplifier is a device that accepts an input signal and boosts the level of the signal at the output. In the process of amplification, most amplifiers tend to distort the signal. So, one of the key parameters of an amplifier's performance is fidelity and how well the output signal matches the characteristics of the input signal waveform. The other very important parameter is an amplifier's ability to use power efficiently in producing the output. For example, an amplifier operating at only 50% efficiency needs a total of 20 watts to produce 10 watts of output. This difference of 10 watts 50% is wasted as heat. Traditional amplifiers use an analog design technique, which unfortunately results in a compromise between the linearity of performance and efficiency. Tripath has been able to combine advances in DSP technology, mixed signal IC technology, power IC technology, and novel IC packaging to create an extremely efficient, superior quality amplification function that is implemented digitally. We are making semiconductor-based amplifiers using our digital power processing technology, DPP, which enables us to make high-performance and highly efficient amplifiers that enable new applications in a broad field of markets ranging from consumer electronics to telecommunications to industrial controller robotics. By then, Tripath already sold 3 million chips. Manufacturers used them in devices ranging from multimedia speaker systems, DVD receivers, cable set-top products, high-definition flat-panel TVs, pro audio amplifiers, automotive power amplifiers, subwoofer amplifiers, and high-power stereo amplifiers. Some of the well-known low-power amplifiers based on the TP2020 chip were the Sonic Impact, Topping TP20, Hilly T-Amp 20, Kingrex T20U, and of course the infamous Lepi LP 2020A+, which was a budget amplifier that surprised everyone. Many have taken to modify them with better components. NSMT loudspeakers were at one point selling modified upgraded versions of the LP 2020A+ amplifier in a nice wooden case, and won an award for their work in 2013. The LP 2020A+ and its versions spawned so many forum posts that you'd think that it was the only Tripath amplifier out there. Here is a schematic for the LP 2020A+ with the blue board, revision 130828. I'll leave a link in the description to the web page for the author's drawing. This second schematic is for an earlier version, LP 2020, without the tone defeat and relay protection components. Most of the forum posts about modifications to the LP 2020 can be taken with a grain of salt. Use your common sense. It is what it is, and there is not a whole lot you can do. In looking it over, I see electrolytic capacitor replacement, input capacitor replacement, and replacing those awful speaker and input jacks. I have a viable approach for that, and I know many videos have been posted, but being late in the game, I'll probably post something in the future. I also recently purchased a LEPI LP 2051, which used the Tripath TK 2051 chipset. This chipset comprises of a TC2000 controller and TP2150 50 watt per channel power stage. I could not find much information on this amplifier, even at the old LEPI website at the Internet Archive, so they must have made a limited number. Hi-Fi Me DIY still sells some Tripath boards and also their DX200 amplifier that uses the TC2000 controller driving a power stage made by STMicroelectronics, which delivers 150 watts per channel. There was a long list of companies using Tripath chips, including a few high-end manufacturers such as Audio Research, Belcanto, Carver, and a long list of consumer electronics manufacturers including Aiwa, Apex, Apple, Denon, Hitachi, Onkyo, Panasonic, Samsung, Sharp, Sony, Toshiba, and others. Profusion UK purchased all the remaining stock of Tripath chips when they went out of business. They still have remaining stock of several types of chips, controllers, and chipsets. So you might ask, how does a basic Class D amplifier work, and how did Tripath do it? Here is part of a chart from International Rectifier showing a simple Class D. I will put a web link to IR's tutorial article in the video description. A Class D amplifier uses a modulation of the input signal called pulse width modulation, which converts the audio signal into pulses, generally a 100 kHz to 200 kHz triangle waveform. The duration of the pulse is changed while modulation frequency is constant to convey the audio information. Then a low-pass filter is inserted between the output and the speaker to smooth out the waveform and remove unwanted signal. Class D is more efficient because the output transistors are either fully on or fully off. From their white paper, what Tripath did was, instead of using the standard pulse width modulation, they used proprietary algorithms and techniques to create the modulation that drives the switching transistors. The waveform for a Tripath Class D amplifier is a complex digital waveform of varying frequency. Their Class D amplifiers switched the output transistors in a fashion similar to spread spectrum technology, at a varying rate up to 1.5 MHz and averaged 600 kHz to 700 kHz, which they called their digital power processing technology. Besides single chips like the TA2020, in January of 2004, Tripath released their Godzilla power stage architecture with the addition of 4 CMOS Class T digital amplifier devices. The TPD2075 and TPD2125 were groundbreaking at the time, but may have never made it to market. The TPD2125 is a high-speed dual complementary MOSFET driver that was suitable for driving a complementary pair of MOSFETs in a dual half-bridge or single full-bridge configuration that could deliver a wide range of high-power levels. When 3 TDP2125s were armated with a TCD6000, the chipset provided a 6-channel, digital input, 75 watt, 8 ohms, per channel amplifier. You have to wonder, if Tripath could have stayed in business, what they would have came up with compared to something like the Texas Instruments TAS3251, which is a 175 watt stereo, 350 watt mono Ultra HD digital input Class D amplifier with advanced DSP processing. Many of the better amplifiers using Tripath technology use the TK2050, TK2051, and TK2150 chipsets. These chipsets were comprised of a TC2000 or TC2000 and one controller coupled to a TK2051, 50 watt per channel power stage, such as the LEPI LP 2051 that I purchased recently, or a TK2150 200 watt per channel power stage. A number of high-end manufacturers coupled Tripath's controllers and drivers to various MOSFET power stages such as Belcanto's Evo 2, which used the TA3020 driver and MOSFET output stage and provided 360 watts per channel. I would like to get a hold of one of those old Evo 2 amplifiers. They were produced around the year 2000. Others used the TC2000, TC2001 chips coupled to ST Microelectronics STA516B. So in retrospect, we can thank Tripath for bringing improvement to existing Class D amplifiers.